So, let us continue our discussion on this cloud computing course. Rather, we were discussing about little bit more relevant topics or which are little bit above the general overview. So, what I believe that you have already seen the other lectures which gives a overview of the overall cloud computing thing, and today we will be mostly looking at that the challenges in resource management, also the problem related to service placement in a cloud fog edge type of thing. These lectures, as I mentioned in my previous this couple of lectures, as I mentioned in my previous talk, that we will be concentrating more on cloud fog paradigm, rather cloud fog edge paradigm, and why it is important to realize a better resource management, better performance in terms of say timing or latency and type of things. So, mostly we will be looking at concepts like resource management issues, and also we will look into the service placement problems. Rather, this will be our base for going to other type of things, like where we will look in subsequent lectures into things like migration issues and other type of things. So, these are keywords. So, just to quick recap, what we have seen, that only cloud only type of scenario, that means you have this underlining IoT or sensor devices, and above at the other end the cloud. So, like you have some of the things like health parameter, like the type of things we discussed last lecture, that you have body sensor networks or different sensors which has this different type of health parameters, and that it uploads in a cloud, it computes the whole thing and return the result to the either to the device of the mobile device of the display unit or any other display unit of the patient or the client, right. So, what we have seen, that processing IoT application directly to the cloud may not be always efficient solution, because especially for time sensitive things, right, where it requires more time, and not only those things, it have a lot of resources, right, like lot of data being communicated over the this network. So, a promising alternative, what we have seen, that making a fog edge computing thing paradigm. So, these paradigm imposed to process large amounts of generated data close to the data sources rather than the cloud. So, the what we have seen, that it is by the definition it is bringing down. So, one of the consideration of this cloud based fog environment is the resource management, definitely, right. Like so, it is not always a win-win situation, like you go on increasing your IoT devices, and then you expect that your edge intelligence or the fog infrastructure will take care, that may not be true. Not only that, in number of cases what we will see, what is been seen, that some of the resource may be over constrained and some may have still something spare. So, appropriate managing these resources is also necessity. There is a another point to be noted, whenever we want to do any type of management thing which may not be there in the cloud only scenario, it also brings about some costing, right. So, a fog resource managers per se should work, and that fellow will also it has not only some resources, it takes time to do the things, right. So, nevertheless, some sort of a resource management at this down the layers, fog edge type of layers is necessary, that is there, right. And it is sort of a resource allocation. If so, this amount of resources are there, how it will be allocated, workload balancing, right. So, it should be somewhat equi-distributed as far as possible, right. Resource provisioning, task scheduling, QoS, maintaining appropriate QoS level and type of things are coming into play. So, in other sense we see there is a whole lot of things come into play. Nevertheless, means in spite of handling this type of scenario, this type of paradigm where cloud with fog and edge may be beneficial, that we want to see. So, our today's talk is mostly hover around how this resource management things will be, what are the different parameters or what are the different characteristics of this resource management problem. So, what we just to continue from the previous slide. So, fog edge to support for the cloud computing paradigm. So, the major issue is the latency issue, right, like may involve transfer of data for each single sensor to the cloud. So, whereas this, if we have this paradigm, it will reduce that communication, likely to reduce. That means, as we have seen that I can aggregate the data in cases if it is possible and then transmit. Some of the things I can respond at the fog or edge layer itself, like some of the call, it may not have to go to that level to things, like as example we were discussed earlier, like if I want to look at the room temperature and want to make a alarm call that the temperature is above the threshold level, that may not has to take the go up to the cloud level and take a call, that my even my sensor, if we have a more computing things, that means at the edge itself I can take, if the temperature is more than something, it sets up the alarm and say that it is there. Sometimes it is aggregation is required, like all the sensors in this room should agreed upon things, like it may happen that one of the sensor may be misbehaving and set up a alarm, and whereas if there is a aggregated things. So, that could have been done in a little much higher level, not maybe the edge, those fellows are sensing maybe at the fog level, again I reduce the load on the cloud, right. Or sometimes we want to make a aggregation of this data and then send on the cloud. So, the overall traffic from this fog to the cloud reduces, right. So, these are definitely latency issue. And so, fog edge computing made cloud in overcoming this. So, it is not a substitute, rather it is a supportive or a cooperative or collaborative system came into play, and there are a lot of challenges also come into play, right. Once you collaborate, there are issues of interoperability, there are timing relationship and between these different processes, and things like this comes into play, right. Rather what we will see in this subsequent lecture, this event, this fog layer may help you in making this different type of devices interoperate, right, fog edge layer, right. Like for example, if I am taking say even say come to our example of temperature sensor, if we look at the temperature sensor, that may be a variety of, there may be more than one type of sensor, that means coming from different make and model. So, what will happen? It may end up in sending simple or as basic as that, they may be sending out these temperature things in a different format. For that matter, suppose one is sending in centigrade and one is sending in Fahrenheit. Like now, this making in a uniform conversion could have been done in the either in that edge itself or at the fog layer. So, in other sense it allows me to interoperate in the things, and if there are variety of sensors, so you may can imagine the complexity of the whole thing, right. So, that these three technology can work together to grant what is improved latency, reliability in some cases, like and faster responses, right. So, though these things are interrelated, things are apart from that, there are that will help in at times in interoperability, like to interoperate between the different things, and later on we will see that it also may help in some sort of a what we say information security, right. Now, like some of the things like fog etc., may be in my control or in my premises. So, while sending the data, I can have I aggregate the data. So, individual data is not pinpointed, or even I can strip off this say patient information, the patient like patient identity, and send that data up in the thing, and while coming back I attach it, I number it with the things, right. So, starting from that there are other crypto etc. we can run. We are not going to those complexity. Nevertheless, what we see that it will definitely help in having latency, reliability and faster response, and may at times this trustworthiness and type of things. So, again we look at the same picture or same type of things. So, we have several edge devices or IoT sensors and actuators, like sensing and actuating based on the things, and intermediate we can have a fog layer, right. So, there are different fog layers, and if you can see these fog layers can have different type of resources, like in these cases they are having different virtual machines, right, which takes care of the thing. So, it requires a hardware, a hypervisor and the virtual machines. Once you have, you need to have a fog manager, server manager to manage this. If there are more such things, you need to have some sort of a fog data center or a fog network, which also may require some sort of a management of the things, right. There are other things what we will see, that there are challenges of mobility, right, like as we our edge devices or these IoT things can be mobile. So, this fog things should take care of the things. In other sense, if it is under one paradigm of the one fog device, right, we are considering the fog devices to be stationary, then once it cross and go to the another fog device area. So, that there should be a syncing of the things, that same sensor is sending data, or if there is a data aggregation going on, I may not want to lose this data type of things, right. So, those things are there. There is the underlying communication network definitely, which push it to the cloud. So, there is a request goes on, rather there should be a other way around, as it is actuating some of the it is request, and this other arrow is the request response type of things. So, it sends some request and get a response and actuate on the different type of autonomous mobile sensors and type of things, right. So, what we see that fog environment model typically is composed of 3 layers: a client layer edge, a fog layer and a cloud layer, right. Fog layer is to accomplish requirement of the resources of the client, and if there is no limited availability of the resources in the fog layer, then the request to be passed to the cloud layer, right. So, there may be two scenario where this edge is pushing to the fog is pushing to the cloud. One is that it do not have the capability of computing that type of things, right, that particular analysis or that computing model, or it is getting constrained on the resources. Once it is getting constrained on the resources, especially in the case of a fog, it can delegate to the other what is collaborative fog devices, right, or it can push it to the cloud. Another thing is that it do not have the way to compute this, right, like if I want to say, if we looking at the say all temperature sensors in all over this building, all rooms, and then want to take a call that or in this whole our institute, and then want to take a call that which are the things which are maintaining and which are not maintaining, that individual fog devices, and aggregatedly how many percentage of the this air conditioning systems are working faithfully or in a proper way. So, that can be, so this global thing can be done at a cloud level, right. So, the major functionality. So, what we see, if we have this type of fog edge layer, so major functionality is that there should be a fog server manager, which employs all available processors to the client, right. And there are definitely VMs operate on the fog data server, process them, then delivers to the result to the fog manager, and fog servers contain fog server manager virtual machine to manage this using a server virtualization technique, etc. So, in other sense, the type of virtualization techniques and computing things that comes down below that the fog layer from the cloud infrastructure. So, that may be a overall managing this fog layer, right. So, this type of things may make lot of sense in application specific domains, right. It will change over domain. Like if we look at say something like vehicular ad hoc network type of things, right, where we have underlining these cars and vehicles which are having their own sensing units, and not only that, they are having that onboard units or OBUs, and it communicates with either another car, right. So, if I look at these are the edges, right, with sensors at the down. So, it can either communicate with the things what we say V2V communication, vehicle to vehicle, or it communicates with the roadside infrastructure. So, V2I infrastructure, right. This roadside infrastructure is connected to a backend cloud data center. So, for all type of things, suppose a revocation of one license etcetera, or something is there, certificate is there, then it is basically taken a call at a much higher level and done like that. Something is misbehaving or something is happened, means something is some group of car is misbehaving, like slowing down not expected. So, it may have to be taken a call that whether there is a call in there is a accident in front and type of things, which may have to be correlated with other informations which is known to the cloud, right. So, that type of things are there. So, what is happening now, this infrastructure may maintain different resources where different virtual machines etcetera are there, and it has a separate things which acts as a fog layer for all those things, and which push it to the cloud. Cloud also can definitely have other means resource management things, right. So, it can be different. So, this is one scenario. If we look at the scenario like healthcare systems, then we have, say, if we have a body area network. So, it captures the things, transmit to a nearest hop, or it may be a local server, or even a mobile device which acts as a fog, and in turn it push it to the back end health cloud and type of things, right. It can be that way also. So, in case of a say vehicular network, it can be too much mobile, right. It is make and break are there, where in case of a other scenarios like either health or like temperature measurement or temperature, humidity and etcetera measurement across the rooms, those are more or less static sensors, they are not moving around now and then. So, the trend as we can see is to centralize some of the computing resources available in large computing server things. That is why we are having this fog, as we have seen, dedicated micro data centers and like internet nodes such as routers, gateways, switches are augmented for the computing facilities. And another set of definition, I kept it little in italics, that because you maybe by a time bombard with so many definition, but nevertheless the philosophy is still remains same, bringing down the computing from the cloud to down the to the as much as to the client end or the where the sensor end, so that the computing is more facilitated, right. So, if we look the overall resource management paradigm. So, this is the thing which we referring, that reference is given below, a nice, very nice survey paper which takes care of this, it deals with lot of things. We will be primarily looking at that stuff. So, if we look at that resource management in fog and edge computing, rather fog, cloud, fog and edge computing. So, we like to divide it into three major components, right. One is architecture wise how they are, infrastructure wise and algorithm wise, which is dealt in this particular reference paper. You can look at the whole document, very nicely written survey paper and pretty recent one, end of 2019. So, and if we look at everything like architecture, so architectures also have different components like segment like data flow, where as we are discussing that aggregation of the data or sharing and offloading of the data, right. So, like aggregating the data if it is makes sense, sharing information for other computing purpose or things, and offloading to other devices or offloading to cloud and type of things. Control, another aspect is the control, right, which looks as the whether the control is a centralized control. Even if we look at the fog layer itself, whether it is a centralized control or distributed, or it can be hierarchical control, right. I can have different layers of hierarchical control. So, this now we are having these fog edge things in a much bigger perspective. When we look at the infrastructure, so infrastructure, whether we are looking at hardware infrastructure or system software or middleware, right. So, different aspects are being studied or lot of research going on that how overall things works, right. So, on the other side, given that we have a infrastructure and architecture in place, what are the different type of algorithms which will come into play, like things like discovering the resources or benchmarking the resources or how things will work, load balancing issues or load balances algorithms, and there are challenges of placement, right. Given a job, where do I place, right, the job. Even if you can see that even those who have gone through distributed network, distributed computing type of paradigm, they are also what we have seen that this placement of the things is are challenges. Rather, all these components are somewhat present in those type of scenarios. So, if we look at the resource management approaches, one is the architecture, as we are discussing, used for resource management in cloud fog edge computing based on data flow or classified data flow control and tenancy, right, but where it will be there, where it will be residing, right. So, tenancy. Infrastructure, the again infrastructure composed of, as we have seen, hardware and software to manage the thing, network, storage resources for application and this like overall resources, how it can be managed, right. And on the other side we have the algorithms. So, underlining algorithms to facilitate cloud fog edge computing paradigms. So, these are the things which are very much needed for this type of scenarios, right. So, again coming back to the figure, if we want to have resource management, so these are the major component and where it need to be, we need to look into. Now, let us see one component other. So, architecture, if we look at the architecture, as we have seen, it is data flow, right, control and tenancy. So, it is based on the direction of the movement of workloads, right, when we talk about the data flow in the computing, overall computing ecosystems, right. So, workload can be transferred from the user to the devices to the edge nodes, or alternatively the cloud server to the edge nodes and type of things. So, how this data is flowing based on your application requirement also dictates how the resource need to be managed, right. Like if I say my data is from the user end to the edge and fog, and they are likely to be computed and come back, then I have to make the resource management that way. If I want that the requirement is the data has to travel to the cloud and something has to be done at the cloud and come back, then I have to take care of that so called intermediate this computing network resource management also into play vis-a-vis how this data being transferred, etc. Right. The other part is the control. So, based on how the resources are controlled in the computing, overall computing resources, for a single controller or a centralized algorithm may be used for managing a number of edge nodes, or it may be a distributed things. It all depends that how much your overall paradigm is, right. And the thirdly, what we see when we look at the architecture issues, based on the support provided for the hosting multiple entities in the ecosystem, either a single application or multiple application could be hosted on the edge. So, that means if we look at this architecture, so one is that one looks into the one aspect looks into the overall data flow mechanisms, other is the control mechanisms, like how overall resources can be controlled, whether it is in a centralized way or in a distributed way. Suppose I have a one or a set of fog devices more or less within the things, then I can do in a centralized way, or if I have say a fog network itself, then I may have a distributed control into the things, right. There may be issues that based on the applications, like say vehicular network type of scenario, where I may want a distributed computing, because there is a that the vehicle is moving over a large geographical space and things like that, and need to be looked into. Whereas, in a other type of scenario where temperature control etc., which are more or less static things, so I may look for a distribution. So, it also depends on that. And then tenancy means which algorithms which will be running and where they will be residing and where it will be running is an important thing, right. A single application or multiple application hosted on edge nodes, or which things will reside on the things. So, that is also important, that where will be the tenancy. If we look at the infrastructure, as we have seen, the other aspect is the infrastructure. So, there is a things called hardware, system software and middleware, right. So, when we look at the hardware is the things like, if we look at fog edge type of paradigm. So, it exploits the small form factor devices such as network gateway, Wi-Fi router, set top boxes, small home servers, edge ISP servers and so on and so forth. And if we say vehicular things like car and vehicles, even drone as a computing servers for resource efficiency, things like that, right. So, that means, if I having this other resources in place, like if we look at Wi-Fi router or in a vehicular communication car or in a drone capturing images or other information, so drone. So, if we can add on computational module or computational resources, it has a additional computational or unused computational resources, I can utilize, we can utilize that for this fog edge computing, right. Whereas, typically cloud have that sufficient resources to work on, right. And the other aspect is the system software runs directly on the fog edge hardware resources such as CPU, memory and other devices, right. So, once the hardware is there, based on that my system software runs, right. So, it has, there should be a underlying system software which manages the things. It manages resources, distribute them with the fog edge, like operating system, virtualization software and type of things, right. So, those are the things. These are system softwares which are not per se actually the application specific software, right. So, these are more running the devices and type of things. And then we have middleware which runs on the operating system and provides complementary services that are not supported by the system software, right. Like middleware coordinates distributed computing nodes and performs deployment of VM and containers to each, etc. So, these are the middleware which are not typically supported, the jobs which are not typically supported by the system software, but it supports this type of things, as we are seeing that deployment of VM or container in the thing. So, those are the things which are middleware, right, which cut across maybe more than one resources, right. So, if we look at the infrastructure, so these are typical component of infrastructure. And finally, in this paradigm, if we look at that algorithms, so discovery, benchmarking, load balancing and placement. So, these are the 4 major components. So, when you look at, so what we say, infrastructure is in place, the architecture based on the architecture, and now we have the algorithms to run over and above the things, right. So, discovery is identifying the edge resource, so workloads from the cloud or from the user devices can be deployed on them, right. So, this algorithm I should have an underlying algorithm that which resource is free and which are the edge devices where it can run. So, benchmarking is capturing the performance like it may be CPU, it may be storage device, networking and type of things of a computing this. So, it is very much needed because this actually dictates that how overall this overall performance over of the system will be there. And load balancing, as edge data centers are deployed across the network edge, issue of distributing task using say efficient load balancing algorithm has gaining significant importance. Like, so it may deploy different optimization technique, load balancing techniques and different type of searching mechanisms and type of things. So, it is important to have the load balancing, otherwise sometimes it may be skewed into the things, right, if it is going to the hitting the same type of devices. So, this the algorithm need to take care, right. And finally, the challenges of address placement, right? Placement of services and applications, right. Addresses the issue of placing incoming computing task on suitable resources. So, how I can place this resources considering available resources in fog edge layer and environment if there is an environmental change, right. So, it can be dynamic condition aware techniques or iterative techniques. So, we can have different type of things. So, what we see that these 4 components is the algorithmic things. So, now again if we come back to this big picture, right, where this resource management with respect to fog edge, rather cloud fog edge type of paradigm is there. So, one aspect is looking at that what sort of architecture we are having, which has data flow control and tenancy type of issues to be handled. Other part is that the infrastructure, hardware, system, software, middleware, how things are there, and then given this scenario we need to have these appropriate algorithms to run on those things, so that the applications are there. So, our basic bottom line is that this our different sensors which are being there, I want to take a call based on this data, right, whether it can be done at the edge intelligence or at the fog layer or at the cloud based on the things. If I want to use this more efficiently, this fog edge type of paradigm along with the cloud, I need to have a proper resource management, right. We will continue our discussion on this topic or more precisely some of the areas in our subsequent lectures to see that how overall this cloud fog edge paradigm helps us in achieving better performance in the overall what we say this ecosystem. Thank you.